So one of the examples that we're going to do is find the coordinates of the points of inflection for this polynomial. Okay, so we're going to find our first differential, which is 8x cubed plus 12x squared, take away 144x. Then our second differential, which is 24x squared plus 24x, take away 144. And when we're doing points of inflection, every point of inflection, the second differential is equal to 0. So we'll set our second differential as equal to 0. So that means that 24x squared plus 24x, take 144, is equal to 0. Okay, I'm going to take out 24 as a factor, so I've got x squared plus x, take away 6, equals 0. So I can factorise that. X plus 3x take 2. So that means that x equals negative 3 and x equals 2. Okay, so these are the two possible x coordinates where we could have point of inflections, but we need to check either side to see if they actually are points of inflection. Remember, we need to check the second differential and see if it changes sign. Okay, so we're going to do when x is equal to, or one side of negative 3, so we'll do negative 3.1. Our second differential is equal to, our second differential, we have, I'm going to use the original, 24 times negative 3.1 all squared plus 24 times negative 3.1, take away 144, equals 12.24. And then the other side of negative 3 is negative 2.9. We've got 24 times negative 2.9 all squared plus 24 times negative 2.9, take 144, negative 11.76. So 12.24 is greater than 0. So at that section we've got a convex. Negative 11.76 is less than 0. So at that point we've got concave. Okay, so there's been a change in sign of my second differential. So I know that negative 3, there's a point of inflection. I've now got to check x equals 2. So we'll try when x equals 1.9. Our second differential is equal. Remember, pick values that are actually close to the one you're trying to test. I'm not going to use 5 and negative 1 close to it 2. Okay, you need to pick kind of values that are relatively close. So 1.9 all squared plus 24 times 1.9, take 144, negative 11.76. which is less than 0. And then I'm going to try when x equals 2.1. Our second differential is equal to, so 24 times 2.1 all squared plus 24 times 2.1 and take away 144, 12.24, which is greater than 0, so greater than 0 there's convex, less than 0 there's concave. So there's been a change of sign in our second differential there as well, which is what we look for when we've got a point of inflection. Okay, because it's, it changes between convex and concave. That's the definition of our point of inflection. So we need to write a final statement. So hence, the points there are 2 points of inflection at x equals -3 and x equals 2. But we weren't asked for the x coordinate, we were asked for the whole coordinate. Okay, so we need to sub those values in. So when x equals -3, y equals, we've got -3, so subbing it back into the original equation, so 2 lots of -3 all to the power of 4 plus 4 lots of -3 to the power of 3, take away 72 times -3 all squared, all squared is equal to -594. When x is equal to 2, y is equal to 2 times 2 to the power of 4 plus 4 times 2 to the power of 3, take away 72 times 2 squared, -224. So hence, the points of inflection are -3, -594, and 2, -224.